Hey, what's going on, guys? Mr. Flores here, and this is a video that's going to talk about scatterplots. Okay, I'm going to do two videos for scatterplots. The first one's going to talk about scatterplots and kind of what they are and how we can use them to interpret data, and then the second video is going to talk about something called a line of best fit, which I'm going to get into. Alright, so there's going to be two videos on scatterplots, and this is the first one. So basically, a scatterplot is a visual representation of data used to make inferences on the data. Okay, and scatterplots, they're used, it's basically a graph form. Okay, so a scatterplot is just a graph with a whole bunch of dots on it. Okay, so if we look over here, this is some data that I have. Okay, and it's just data that I got. We're basically going to use a scatterplot to look at the relationship between age and the shoe size that a student has or the person has. Okay, so basically the first thing you want to do whenever you get scatterplots is you're going to draw them. You're going to draw our scatterplot on a graph, and we're going to plot the points. Okay, but of course, whenever you have a graph, the first thing you always want to do is label your axes. All right, so this is our x-axis, this is our y-axis. Our x-axis is going to be the age, and the y-axis is going to be shoe size. Okay. The reason why the x-axis is going to be the age is because really when we talk about age and shoe size, your age determines your shoe size. All right. Basically your shoe size depends on whatever your age is. Okay. So that's how you can kind of figure out which variable is your y and which one's your x. Okay. And then once we decide which is our x and y variable, we must also label our axes. Okay. Since our age starts at 7, and that's the youngest one we have for our data, I'm going to start here with a 7 and then just count by ones. So it's 7, 8, 9, 10, 11, 12, and 13. All right. And then shoe size, coincidentally, I'm also going to start at 7. Okay, so it'll be 7, 8, 9, 10, 11, and 12. Okay, but we're not going to have to go that high, all right, because we're just going to see how the data is plotted. All right, so in the last step to a scatter plot, all you do is just plot your points on their coordinates, or plot the points on the graph using the coordinates that you're given. So the age is 7, shoe size is 6. Oops, actually I just noticed I didn't go high enough, I didn't go low enough for my y-axis. All right, so that's not going to work. Alright, so I just got to rewrite it. So again, the lowest one is, I'm going to start at 6. So it's going to be 6, 7, 8, 9, 10, 11, 12. Alright, so we're going to go down to, at 7, we're up at 6. Okay, at 11, we're at 8. Alright, at 10, we're at 9. 9, we're at 7. 12, we're at 9. 11, we're at 7. And then at 12, we're up at 8. Okay, so as you can see, this is our data. All right, and generally with a scatter plot, you're going to have a decent amount of data points, and really what you're looking for is you're looking for some type of relationship, all right, between your points. You want to see a casual trend, or basically you want your data to act in a way such that we can make an inference on it. Okay, and what that inference is called is the correlation of data. Okay, so another vocab word we're going to talk about is correlation. Okay, and correlation is the general movement of your data on your graph. Okay, so basically, since we're talking about graphs, we really want to talk about things that are linear. We're going to talk about lines, okay? So basically, you want to look at your data and check to see how is it acting if it were a line. So let's kind of see if we can just draw a linear line that goes through most of our data points. Okay, and that's what this dotted line is representing. Okay, so if you look and you notice I drew this purple dotted line that goes through most of our data points. Okay, and using this line we can talk about what type of correlation or relationship is between our data. All right. If we look at this line, we know that it is increasing. Okay. And we want to think about what is the slope of an increasing line. Well, if this line is increasing, which it is, the slope has to be positive. Therefore, we have a positive correlation. Okay, and basically what correlation means, and a positive correlation more specifically, means that as your x variable increases, your other variable increases. Okay, both variables are increasing at the same rate. And why we can say that this line would have a positive slope is because the change in y, or the change in shoe size, is increasing. So the change in y is positive. The change in age is positive. Positive over positive is still positive, therefore it's a positive correlation. Okay, but again, you can just look at your data most of the time and already see what type of correlation it is. Right. So just another quick little vocab term, that this black line is called our line of best fit. Okay, and if you watch the next video, it's going to talk more about the line of best fit. Another name for that is called your linear regression line, but you probably won't really come into contact with it unless you take statistics in senior year or in college. But we're going to use the term line of best fit, okay? And again, I'm going to make a video that's going to use this line, and we're going to be able to make some inferences on it, okay? But basically what I want you to get from this little problem right here is that when you are given data and you're creating a scatter plot, you must always label your axes first, okay? Then plot your points. Then you want to see what type of correlation does the data have. And as you can see, our data is increasing, and all of our points are generally in the same location. Therefore, we're going to have a positive correlation. Okay. So what I'm going to do here is I'm just going to draw a couple scatter plots. All right. And we're going to talk about the different correlations that we could have. All right. So if you look at this scatter plot, we can already tell that the type of correlation for this one is going to be negative correlation, right? Because as our nope, that's not what I meant to say. Correlation, okay? So as our points, as our x variable is increasing, the y variable is actually decreasing since our line is going down. Okay, if I were to draw the line of best fit, this would have a negative slope. Therefore, we know that it is a negative correlation. Okay. And that's the other type of correlation is negative. Another type would look like this. Okay. If you look at the data, there's really no real relationship between the x and y variables. Okay. Because if we look here, there's really not one line of best fit that I could draw that would really interpret our data. Okay. Because if I try and draw one that's increasing, there's a lot of points that don't encompass it. But then if I also try and draw a line that's decreasing, okay, you really can't get many points that encompass it. So this would just have no correlation, okay? If there's no relationship between the x and y variables and how they increase and decrease, there's just no correlation. And that's perfectly fine, okay? Some things in life don't have a correlation among each other. And we're going to see in the next example how we can kind of decipher correlations without looking at graphs, okay? So that's negative correlation. This would be a no correlation since there's no real strong correlate or a strong relationship between the two variables. Okay, and lastly, if we look over here in the bottom left, okay, this is very similar to the one we just did. Okay, because if you try and draw your line of best fit, your line of best fit is going to be increasing. Okay, it's going to be going up, so therefore that's going to be a positive correlation. Okay, that's positive correlation. So therefore you have the three main types of correlation. There's negative correlation, no correlation, positive correlation. Of course, we can get more in depth with different types of correlation because there's quadratic, linear, exponential, so on and so forth. But for our sake, this is all we need to talk about. Does it have a positive, negative, or no correlation? All right, lastly, we're going to talk about correlation not given a graph, but just given two variables or two situations. Okay, so if we look here, we have a shoe's sole size, or how thick a shoe's sole is, in regards to the miles walked in the shoes. Okay, so basically what you want to do here is you want to see if as one increases, what does the other variable do? Whereas one decreases, what does the other one do? So if we notice that as a shoe's sole goes down, miles walked goes up. Okay, since both of these move in opposite directions, this would be a negative correlation. Okay, since the shoe size is going down, the sole size is going down as the miles walked goes up. All right. Next one would be hours studied and grade on a test. Well, generally, the more hours you study, the higher test grade you're going to get. Okay, so as your hours studied goes up, the grade on a test goes up. Therefore, that would be a positive correlation. Okay. Test grade and the color of your shirt. Well, if you think about it, the color of your shirt and your clothes really don't have any bearing on how smart you are or how much you studied. So really, the test grade and the color of your shirt have no correlation. Okay, they're two variables that have no real significance or relationship among the two of them. All right, and lastly, the hours worked out and the amount of weight loss. Okay, so as you work out more hours, you burn more calories and generally would lose more weight. So that would have a positive correlation. Okay. Hours worked out and amount of weight lost would have a positive correlation. Okay, since the more hours you work, the more hours you work out, the more weight you lose. Okay. So basically that is the quick little video on scatterplots. Okay, again, a scatterplot is a visual representation of data used to make inferences on the data. And then the next thing we talked about was correlation. It's the general movement of the data on your graph. Okay, so as you saw here, since our data was increasing, it had a positive correlation. The data is decreasing, negative. If there's no relationship, it's no correlation. And again, if it's going up, it's a positive correlation. Okay. The next video is going to talk about this purple guy right here, which is called our line of best fit. All right, and I'm getting on to more detail about the line of best fit in the next video. But line of best fit is one of those cool things about math because it kind of takes everything we've done graphing-wise, and it kind of brings it all together because we're going to create a line. We're going to use that line to make inferences. We're going to really talk about it on like a deeper level. All right. So if you have questions, you can email me, come see me, or watch the video again. All right. Scatterplots are one of those things that are very, very important. Okay. Again, if you ever take statistics later on in life, you're going to do a lot with scatterplots because they're kind of a big idea. So if you have questions, let me know.